So my name is Charles Irizarry. The reason why I'm in front of you here today is I am the most social engineer of our team. So every once in a while they let me out and I can talk to you guys. And so one of the reasons why they probably keep me back at home is what I'm going to show you guys today. My background is in distributed computing and cloud architectures, a big focus in an area called reinforcement learning. Very simply put, that's just making machines teach themselves. And so recently we had a couple great breakthroughs. And for the last few years, we've been applying agentic science, or what you may have heard of agents, into business. And so what I'm going to be showing you is what we've done, what we're seeing happening, our predictions of where the future is going to go, and hopefully some ideas to help you kind of get started. Make sense? So remember, on this one, smile. So we were reached out by several organizations, surveying, talking to AI researchers on our predictions on when we think AI will completely automate human jobs. The consensus is at 50 years. I myself, together with leaders like Geoffrey Hinton, who's the godfather of deep learning, think it's much closer. And some of the things that we're automating today are pretty impressive, and they're automating entire departments of businesses. What's important, an important decision or choice that every leader has to make, and I call this the inescapable choice, is do you adapt or become obsolete? And the reason I say that, considering that in our lifetimes, we're going to see complete human automation, it's not about competing or adopting a new form of technology to compete in the future landscape of business. If you don't adapt, you won't survive the future landscape of business. And so this is much more about survival than it is about building a new app or a new website. I'm going to walk you guys through a couple use cases that are happening right now today. And we're going to start with a very, very large law firm that we started working with. This law firm is what we call an insurance defense law firm. And they deal with a lot of invoice rejections. Just to give you a little bit on what's happening here. When you're dealing with insurance companies and you send them an invoice, they're very, very good at not paying the invoice. So what happens is that when that invoice goes to the insurance company, that insurance company has an army of people that redline line by line and say, I'm not going to pay for this. I should pay less. You took too much time. And they send it back to you. So the the law firm has to get their own army of people to respond back to those red lines. And it's a huge bureaucracy that goes back and forth, back and forth. When they reached out to us, they said, look, we don't think AI can do this, but can AI do this? Challenge accepted. And so we started with a couple of agents. Now we're about 13, 14 agents. These agents are able to read contracts, read invoices, read the requirements of each insurance company. They're able to predict how the insurance company is going to reject the invoice before the insurance company rejects it. So they can pre-draft the response to the insurance company. Now, the really fun thing that I loved most about this project when we launched it was that the people that we were fighting with on the other side were attorneys. And so as the appeals came in, we responded back. Another problem that we had was that our agents were moving too fast. They were responding just as fast as the invoice came in. So some insurance company were saying, what are you doing that you're responding so quick to us? And so we, as an engineer, we had to implement this concept called sleeping, which is the agent can't immediately respond. They have to take a day, 3 days, 7 days, a random period of time, so the humans on the other side didn't know it was AI talking to them. The results were pretty impressive. For the 10 million rejected invoices, manually fighting for them, they got about a 50% yield. The cost of that 50% yield was about $3.5 million a year. We brought it from 50% to 70%, and we brought the cost down to a little under $750,000. So nearly a fraction of the cost to actually get that money. Here's the kicker. When the law firm started to realize the performance of this, and again, 70% yield against attorneys. So it's AI beating attorneys on the arguments of what they should pay. And lawyers really don't want to pay for stuff. The CIO asked us, hey, if you guys can do this so easily with all of these invoices, could we change the rules to chase anything that's worth less than $100? Because when we did it with humans before, we didn't want them spending time on 20-cent things or $5 things. We said, absolutely, we can turn that on with no effort. That introduced a net new $1 million of recovery for them to chase. This was the first time I saw a physical 280-pound man dance with no music. And it's a moment I will cherish. So this department within the legal firm, it's about 14 paralegals. It's being scaled down to 3. All the paralegals are being moved into revenue generating activity with the attorneys on the other side to increase the more billable hours. So it becomes the resources that they start to save, the capacity that they start to gain starts to immediately grow the business right off the bat. Here's another one. It's a lot of fun. So I knew this world existed. I just never saw the inside of this world. This company, they do global buying and trading of commodities, specifically seafood. Not only do they buy tonnage of seafood from companies, they buy from countries. They sign it on a piece of paper, and they keep track of currency exchanges. And when the arbitrage is high enough, they sell it to another country, and they make the difference. It's a brilliant business. The problem is they have 40 humans making all the buying decisions. And so when we went to talk to them, we asked them, hey, how do you do this? And these are wise guys with grays in their hairs. And it's like, well, it's a little bit more of an art than a science. And I watch the news, watch the stock markets in every country, pay attention to politics, understand what the zeitgeist of consumers are. And then based off of that, I lick my finger, put it in the air, and I make a buying decision. So it's like, great, I think we can do that. And so they asked us, the CEO said, look, these guys are brilliant, but this is not sustainable. Some of them are getting older. They're going to start retiring. How do I capture their knowledge and actually build a sustainable way to actually buy and sell profitably across these markets? So we entered into the project and we deployed agents in 2 stages. The first stage is agents completely focusing on the research and the consolidation of data. The beauty about this market was that everything was publicly available. Countries are putting down their budgets, what they're buying, what they're spending. Markets I can reach, stock trading markets, currency exchange is a public available information. In addition to that, we were able to mine their internal data, their emails, their paperwork, their contracts, their notes. So we were able to generate agents that understood how they made decisions. It's called inference. So by inferencing that knowledge, we were able to make agents with the decision trees that they needed to make the same decisions they would. The difference is they could do it 1,000 times a second. Second phase was delivering the daily decision report. When we did the first demo of this, the CEO asked me, how were you able to make the agent seem like it's been in this business for 20 years? And what I told it was, it's not that we know anything about the business, is that the agents can process and understand all the data that you have and then turn that into something actionable. And that's why it feels like they're experts. And so as we bring this project to production, the buyers get decision reports every day. They get to review it, and they are able to make their buying decisions first thing in the morning. Everything is documented, logged, explained. The agents explain why they made these decisions. They explain the predictions that they're going to see in the market. They pass it on to the buyers, and the buyers make the final call. This was only possible because of recent innovations in AI. How many of you have heard of a little startup called ChatGPT? Yeah, small company, you may not have heard of them. They were able to introduce the world a concept called digital cognition. Fun fact, Google invented it. OpenAI was just the first to market with a product. The biggest blocker that we've had in the research field of AI was how can we mimic human cognition as accurately as possible? And that's a lot of the work that we did, especially in reinforcement learning. How do we get a machine to learn, experiment with an environment, understand the consequences of their decisions, and actually take wisdom from that? With digital cognition, it remembered, it reasons, it weighs, it actually forecasts several different futures and then decides what to do with those futures. Many people don't know this, but AI was actually a born science from neuroscience. AI has been trying to explore how does the human brain work and how do we replicate it. When Geoffrey Hinton invented deep learning as a neuroscientist, he was just trying to replicate the behavior of synapses in a brain. He didn't realize that his life's work would end up to be what it is today, which is the large language models. Have you guys heard of large language models before? Is that a word? Okay. So what is an AI agent? An AI agent, this is the simplest term that I can give you, but technically speaking, and I like being technical because it makes you cool at parties, is software with agency. So this is actually the technical term. This is where the name comes from. And it's the idea that software can operate autonomously. We didn't have that until 3 years ago when we started applying it right away. While everyone was really excited that there's an AI that can write my email, we were trying to take that same AI and make business decisions. You guys use digital cognition today. If you're using ChatGPT, Gemini, Claude, whatever the case may be, if you're typing a text right now and it's auto-completing for you, you're using digital cognition whether you realize it or not. It's all around us. It's here. It's implemented and it's in production. And so the difference is the techniques of application and how it gets used. And we use it through agents. Now, there's a couple concepts I'm going to show you here. If you guys ever want to see more of this, I have a very handsome, tall partner in an Oxford blue suit right here. He can give you a very Jurassic Park-like experience where the developers will be behind the glass and we're working on our stuff and you can see the things that we're doing. But what I want to share with you is how we organize the systems in the background, how we automatize how agents function, and then how do we apply them to business. The first part of any agent is the ability to perceive. This is actually one of the harder parts. How do we get an agent to observe an environment? It could be digital for the most part, and it can be physical. Computer vision has come a long way. So we do have use cases where we use security cameras to understand the flow of people in a certain area, specifically in airports or common communal environments. If the agent can perceive, it then can decide. What do I do? What did I see? Should I do something? If I do something, what should that be? And will that deliver the outcome or the goal or the results that I want? After it's made its decision, and by the way, this happens in nanoseconds, it acts. This is another tough part of agency. How do we get all the tools available to the agent? How does the agent understand how the tools function and what they're going to get out of it so they can actually properly influence the environment that they want to influence and get the results they're looking for? And then this is the most important link in the chain: feedback loop. It's how it learns. So if anyone's in marketing, I always make the joke that the easiest way to understand reinforcement learning is A/B testing. Do you guys know what that is? When you do advertisements, you put one ad up, see what it does. Then you make 3 versions of that. And then you put those 3 ads up and see which one does better. And then you do 3 versions of that and you keep going. That's what the agent does. 1,000 times a second, trying to understand the best way to get the results it wants. We refer to this as the cognitive multiplier. So as a human might think through something, it might take them a few seconds to think through that, rationalize. There's the free mind principle, where the human brain is one of the best brains at predicting certain outcomes. That may take us seconds up to a minute. The agents are able to do it in nanoseconds. And so the trick is, how do we get the agents to think like us, learn from our wisdom, and then actually augment us and multiply our capacity? That's a lot of the work that we do. Now, there's a lot of conflation between the concept of generative AI and agentic AI. How many of you knew about agents before today? So a few of you. How many of you now know about agents? All of you guys. Come on. So generative AI, which is the ChatGPTs of the world, always has to be prompted. It's what we call a RESTful application. You have to poke it for it to do something. You have to ask it a question, tell it to do something, whatever the case may be. When it outputs something for you, let's say, a lot of times I have it make, the last time that was really critical to me was I had it write my brother-in-law's speech that I had to give at his wedding. And it was very good, but I had to iterate on it. And so what happens is that you have to continue iterating on that piece. So give it more context, ask it to change things around, so on and so forth, until you get the final output, which is content. It doesn't matter what you're doing, you're always gonna get content in it. It's either text, it's a picture, and I hope you guys are playing with the new Google Nano Banana. Have anyone heard about that? You can put your face in there, tell it to make a movie about you with any kind of ideas you want, and it makes a full 3-minute movie about you. It looks super realistic. So if I can give you anything, take that home and go do that. Agents are a very different animal. Not technically speaking, but different. They observe. They don't need to be told. They don't need to be triggered. You don't need to prompt them. They will observe their environment and act. They function completely autonomous. Once they have their set directions, once you have told them what you expect out of them, the results that you're looking for, they do the rest. They start to figure out how to deliver those results. And what they deliver is outcomes. We specifically term this outcomes when we talk to C-suite executives, investors, legislative bodies, world governments. We just came back from the European Central Bank explaining these concepts to them. The difference between generative AI and agentic AI is that generative gives you content. Agentic gives you results. Content does not change a business. The results do. So when an agent is constantly trying to convert fresh new leads at the top of the funnel, its focus is on its ability to convert the leads, not what's the best email message to get them to reply back. They're much more focused on results. This is the fundamental step shift between what generative AI was and where we're going to in agentic science. And what I tell people is that these systems are able to not only automate tasks, which are the most basic automation you can think of, not only roles, but complete processes, business functions, departments, and eventually the whole organization. There's already studies showing that by end of the 2030s, we should have our first company that's publicly traded on the NASDAQ that's ran by a very small group of people, if any, by one. And it's going to be done through agentic science. This is where it compounds. So I told you about agents, how you can control agents, you can define agents, you can deploy them. But what about agents managing agents? And that's where we're spending a lot of our time and research in today. It's a concept that's referred to as meta automation. It's the area above the actual automation that you're automating. These are agents that are able to decide which are the weak ones, which are the strong ones, which ones do I need to retire, which new ones do I need to spawn in to get the result sets I am looking for. Think of it like a coach on a soccer team. That coach is constantly looking to how to improve an agent by changing its instructions, changing its direction, its goals, or maybe I need to get rid of this agent altogether. It's just not functioning with the rest of the team. And by the way, for fun, when you have a group of agents together, it's called a swarm. And so what's really fun when you turn this on is you see the supervising agent trying to make decisions about what they need, and you just start to see the swarm butterfly around it to start working on different tasks. And one of the first things that it does is called automation of tasks, meaning how do I break down my work to the smallest possible piece of decision or task that I have to do and assign an agent to it. So some tasks might take hundreds of agents to complete, but the quality of that output, that outcome will be significantly higher than a team of humans doing it. This is the multiplication effect. What we're working on and what we're developing is what we call the cognitive workforce, the digital cognitive workforce. This is a workforce that we build around teams, typically leadership teams, that is always on, scales without headcount, and learns continuously. Both feedback loops feed back to the agents themselves, but back to the leadership of that team. In this new world that we're going to have to survive together, and I hope all of you guys join us, there's new metrics to measure performance of a company. Yes, you may have those kind of older metrics of what's your EBITDA, what's your profit per head count, other cost structures, KPIs performance, what's your growth rate. But even at the agents, they need their own metrics that you have to measure. This is what we call the critical four. This is something that we use internally. Every agent we design, every agent that we deploy with a customer has to surpass a threshold of all these four. First is the cost per outcome. This is not computation or electricity. This is the cost it takes to get all the data that we need, all the insight we need, the wisdom to then generate an outcome. There's a cost per outcome. It's always the most expensive the first time we deploy. Once the agent starts to learn by itself, that cost goes down because it's building its own wealth of knowledge. Then we have what we call the loop rate. How many loops does it take to get to a good outcome? The shorter, the least amount of loops we can take, the better the outcome, the better the performance of the agent. Then there's accuracy. Have anyone heard about hallucinations? It makes up stuff, yeah? And people say, oh, you don't want to use AI because it has hallucinations. As a developer, that's not a bug, that's a feature. Do you know how many humans use fiction to get what they want? To convince people, make a little white lie just to convince the customer to sign the contract? Agents have that capacity too. They can generate fiction. There's a wonderful study that came out of OpenAI where they're trying to train an agent to log into websites and do a couple tasks for them. Those websites had a thing called CAPTCHA. Do you guys know what CAPTCHA is? Where they have to prove that you're a bot or not? The agent couldn't get past this test. So you know what it did? It took the CAPTCHA and went to a website called TaskRabbit. You guys know what that is? TaskRabbit is like a website where you can put an ad and you can pay a small amount of money and people will do a task for you. So the agent puts the CAPTCHA into TaskRabbit and asks people to answer it for it. After a while, some of the people says, are you a bot? Because I'm not going to answer. Like, what are you trying to do here? And you know what the agent did? Said, no, I'm sorry. It's just that I have a vision impairment and I can't see it properly. Can you just please answer it for me so I can do my work? Technically, it's not lying, but it's just enough fiction to get the human to do what they needed to do so they can move forward. And so we measure accuracy in what it generates. It's a very critical aspect because in AI, yes, we may need to do these fictions as humans, but that's a human decision. With what we do here, we have a little agent that goes underneath to make sure that everything it generates, it's accurate and it comes from a source that we can verify. And then lastly, it's latency. From observation all the way to results, how long did it take? And we try to reduce that time as much as possible for every outcome it produces. The future of work, I think, is very different than what people are expecting. People are expecting that it's going to be the same, just faster. No, we're way past that. We're talking about something that's completely different. What does the business landscape look like when every job can be automated? A whole new set of industries will be born. There's going to be a whole new level, what we call the meta level, that humans are going to be operating at. Because now you will not have to run a business. You can run thousands of businesses with agents supporting you, different concepts interlinked into each other. We also see in vast improvements, and where we think AI is going to do the most good and help is in healthcare. Solving for very complicated problems that we couldn't solve for, and then simulating the results across millions of agentic swarms to figure out what's the best recipe or concoction for a drug that can solve a multitude of illnesses. AI, as a word, artificial intelligence, was coined around 1957 by Dr. McCarthy. Several years later, 6-7 years later, the press asked him, how did you come up with artificial intelligence, that word? And he said, I needed money. So he made up the word. They asked him, what does it mean then? And he goes, I still don't know. It's a briefcase word. So internally, we took that and we said, you know what? We're going to change what AI stands for. AI doesn't stand for artificial intelligence, because at the end of the day, what we're looking at is intelligence. It's not consciousness. It doesn't have feelings. It's not self-aware. It's not subjective, but it is intelligent, because intelligent is a technical term, and it's defined as the mechanism and ability to solve complex problems. It can do that. So what we call AI is augmented intelligence. And so what we see is a future where if you're a law firm and you have a paralegal who has to take care of your invoices and you need to hire more help to do that, instead of hiring more headcount, you hire agents. And instead of getting 5 people, you get 50 people out of it, because it multiplies your capacity. And that's very fundamentally core to how we design our systems even here. And I say this, that the research community in agentic science, we share this passion. So this is a collective buy-in on this. So this is just to let you guys know, if you didn't know about agents before, I hope I piqued your interest. If I've scared you, please smile. AI agents are here. They're already in production. And they're already multiplying. So with that said, I'll leave you with the same choice I leave every executive I talk to. Either adopt or become obsolete. You will have to answer this question no matter what. The difference is how fast you do it. This is your inescapable choice. Thank you.